1 in column 1 is negative 15. All right, so let's also find the cofactor of 2 in the second column. It's the same method. So I want to find the cofactor of 2 in the second column. Okay, so where is that 2? I have to make sure I know where it is so I can apply the correct sign. First of all, 2 in the second column is right here, so it's going to have positive. And this is the 2 here. All right, so the next thing I'm going to do is slash out all the vertical numbers that is in the same column and all the horizontal numbers. Now I'll get the minus. So now remember that 2 is the cofactor. So I'm going to this sign here, plus 2 multiply the determinant of that minus. So the matrix of minus is negative 1, 5, negative 3, 4. And by the way, what do I mean? Everything that is not slashed out, everything that is not slashed out will be in the 2 by 2 matrix. So now I have the matrix of minus. Now I find the determinant of this 2 by 2 matrix. So I have negative 1 multiplied 4 is negative. So I have 2 times parenthesis negative 4 minus negative 3 multiplied 5 is negative 15. Negative 15. I close parenthesis. So minus 4 minus 15 will give me positive 11. Positive 11 multiplied 2 is positive 22. Therefore, the cofactor of 2 in the second column is 22. Cofactor of 2 in the second column is 22. All right, so I will come here and write 22. Right here, 22. And then when I finish this one, I'll write my answer here. So the next thing we want to do is the cofactor of 1 in the third column. So I'll find the cofactor of 1 in the third column. I'm only told to find cofactors. So I want to answer the questions that I'm asked. I'm not told to find the determinant of the 3 by 3 matrix. I'm just told to find the cofactors. And that's what I'm going to do. All right, so I'm looking for the cofactor of 1 in the third column. I got to be careful because you want to know which one is the problem, or which one are you looking for cofactor. So third column 1. So I'm talking about this one here, the 1 in the third column. So now that I find where the place where 1 is, I will cancel all the vertical and the horizontal, and then I will get a matrix of minor. The matrix of minor for 1 in the third column is going to be negative 1, 5, 1, 1. That's a 2 by 2 matrix. And then I will look for the position of 1. The position of 1 in the third column is negative. So I will just have to do minus 1 multiply the determinant of this minor, the matrix of minor. Negative 1 multiply 1 is negative 1. Minus 5 multiply 1 is 5. So the matrix or the determinant of the minor is -1 plus -5 is -6. -6 multiply that -1. The place for that one is here. And so the cofactor is +6. The cofactor is +6. Therefore, I'm just going to write +6 here. I want you to remember that this practice test has answers. When you finish, you go and check your answer. And then if you have to do it again, there are only 20 questions in this practice test. So we want to make sure that all this we take care of make sure we understand. If you don't understand, we go back. Okay, I'm just going to find the cofactor of 1 in the third column. So this is the 1 here. I'm going to cancel, and I'll cancel here. And then -1 multiply 1. Oh, okay, I see. Yeah, -1 multiply 1 is -1 minus -5 is -6. Okay, so the matrix, the determinant of that minor is this. Multiply by -1, and your answer is 6. So the answer is 6. Don't worry about it. Sometimes you don't get the same answer in the, but make sure your calculation is correct. If your calculation is correct, you are good. All right, remember the other day we found the area of a triangle using determinants. The same way you are going to find the area of this triangle. Find the area of the triangle when you are given 3 points. When you are given 3 points, the vertices of the triangle, find the area. The area is 1/2 determinant of this. So we're going to actually use calculator. So we are going to use calculator to find the area. But before we do, we want to fill in. We want to find the vertices. Make sure we fill in the vertices. So the first point is 1, 1. Okay, let's start from here. First point is 0, 0. So 0, 0 is here. So that's the point 0, 0. The point 7, 8 is right here. 7, 8. The point 1, 4 is right here. 1, 4. Okay, so I'll complete so I'm going to use determinant of that, which is the same as area of the triangle. Area of the triangle. The triangle is equal to 1/2. I'm going to write that determinant here. I'm going to write that matrix here. I will put in the coordinates. So 0, 0, 1. The next coordinate is 7, 8, 7, 8, 1. And the last one is 1, 4, 1. Okay, so then I can use the matrix of minus and find the area of this triangle, because I don't really have to. I can use matrices anyway. So this is 0.5 multiplied by 0.5. Anyway, the important thing is that if I'm looking for, if I find the matrix of minus, this will give me 0 multiply that minus. So that's going to be 0, whatever it is. So the first one is going to be, let me start from here, 0.5, and then multiply. This is 0, multiply the matrix of minus of 8, 1, 4, 1, which is going to be 0 anyway. And let me go to my signs again. Plus, minus, plus, minus, plus, minus, plus, minus, plus. Okay. And the second one is going to be minus. So I'm going to have parentheses here. Minus. And I am going to get the matrix of minus for the 0. So the matrix of minus for the 0 is going to be 0, 1. So I have minus 0. And the matrix is going to be 0, 1, 1, 1. Okay, and this matrix is going to be 0 again because I'm multiplying by 0 anyway. So this is going to be 0. So I will only be interested in finding so the next matrix is going to be the matrix of, let me get another beautiful color here. Let me get a beautiful color that can make a difference. All right, so the next matrix is going to be the matrix of, if I draw this, then I will, okay, and so then that's going to be plus, and the sign here is 1, so I am going to 1 multiply the determinant of the minus, and that determinant is going to give me 7, 8, 1, 4, 7, 8, 1, 4, and it's going to be 7 times 4, 28, 28 minus 1, so 28. Take away 1 times 8 is 8. So I have 20. Therefore, the area of that triangle is going to be 1/2 or 0.5 times 20. 28 minus 8 is 20. 1/2 of 20 is 10. So the area, according to our calculation, will be 10 square units. 10 square units. So I have 10 square units or units squared. Ten square units or units squared will be the area of that triangle by cofactors. But if I want to use my calculator to do it, I'll just put that in my calculator and find the area. So I will just edit the matrix, turn my calculator on, and second quit, and then clear, and go to second matrix, and edit matrix A. It doesn't have to be A, and it's a 3 by 3, so this is fine. And then let me edit that matrix. I have 0, enter, 0, enter, 1, enter. And then I have 7, 8, 1, 7, enter, 8, enter, 1, enter. And I have 1, enter, 4, enter, 1, enter. And then I do second quit, and I'll go back to matrix and do matrix maths. And then I'm looking for determinants. So I'm looking for determinants of the matrix in matrix A. So second matrix, close parentheses, find that determinant is 20. 20 divided by 2 is 10. So area by cofactors, area by determinant and cofactors is equal to the area by calculator. So we get it, we did it by cofactors and we have 10, and we did it by determinants with calculator, we got the same. So the area of that triangle is 10. The area of that triangle is 10. So that's how you're going to, this question is already in the test. And that's how you're going to find the area of a triangle when you're given the vertices of the triangle. Okay, if you're just coming in, we are working on determinants of 2 by 2 and 3 by 3, cofactors and minus of 3 by 3 factors, and using it to find the determinants. Okay, remember that all these are in PowerPoint. Also remember that every section has author's video in my lab maths. Don't forget that the test was open on the 9th and close on the 10th. All right, so we are going to do 1 or 2 more determinants and we go to partial fractions. All right, so we look at an equation. In this is the kind they give you and they want to make sure you understand. In this question number 6, somebody wants to make sure you understand how to do determinants without calculator. So you have to do this by hand. But anyway, it's a 2 by 2. So 4 times 3 is 12 minus 7 times x, 7x is equal to determinant of 47. Solve for x. So minus 12 on both sides. This cancels. So negative 7x is equal to 35. Divide both sides by negative 7. So x is equal to negative 5. Therefore, the negative 5. So when you're given a 2 by 2 and one number in the matrix is missing and you're given the determinant, somebody is actually expecting you to know the steps in finding the determinant. All right, so I know you can do number 7. One more question on solving by Cramer's rule using determinants. So let's go to number 5. Solve the system by Cramer's rule. All right, the first thing you want to do is calculate the determinants of coefficients D. First of all, find D, and D is equal to the 2 by 2 matrix for D is 6, 2, 5, 3. And I'm going to find the determinant here. And it's going to give me 6 times 3, 18. 18 minus 2 times 5, 10. All right, so, and that gives me 8. So determinant of the coefficients is 8. Now the next thing is to find the determinant of x, dx. So I will form that determinant by omitting x. Wherever I see x, I will put the, I have 0, negative 2. So on the column for x, I put constants. And then I put in the coefficients of y. And then I find the determinant. You don't have to use calculator. Sometimes it's easier to do it by hand. So 0 times 3 is 0 minus negative, negative, negative. 2 times 5 is 10. So the determinant is 10. So the determinant is 10. Whenever the determinant is not 0, you can continue. But whenever the determinant of the coefficient matrix is 0, when you are trying to solve by Cramer's rule, then you must use another method. So this determinant of coefficient matrix is not 0. The reason is that you're not allowed to divide by 0. Not allowed to divide by 0. So now I can find the value of x. I know the determinant of the coefficient matrix. I know dx. Therefore, x, not dx this time, x is equal to d over dx. And d, I'm sorry, I just have to rewrite this. Okay. All right. So x is equal to dx over d. The other way around. This is the best. This is the right way. And then what is my dx? My dx is 10, determinant of x. And what is my value of d? My value of d is 8. Okay, so dx divided by d is 5 over 4. 5 over 4. Or you can write your answer as 1.25 or 1/1/4. So, but this is dx. Now, the next thing we're going to, that is x though. Then we want to find dy. As soon as we find dy, we can immediately find the value of y. All right, let's find dy. dy is equal to, I will write the coefficient, the determinant. So x will have, the coefficients of x will be here. Where the coefficients of y should be, the constant will replace it. Constants will replace that. And then I will find the determinant. So the determinant will be negative 12 minus 0 is the same as negative 12. All right, so now I'm ready to find the value of y. So I'm ready to find the value of y. So the value of y using Cramer's rule is y equal to dy over d. dy is negative 12. And our dx, let's go back and see, over d. Let's go back and see our d. So the value of d is 8. Then divide the value of dy by 8. And then we have 4 can go through. I have negative 3 over 2. I can leave my answer like this, negative 3 over 2 or negative 1.5. So this is the value of y. So we have solved the system by Cramer's rule. If you're not told to solve by Cramer's rule, by all means, you don't have to solve by Cramer's rule. All right, so you're told to solve by substitution. Now everybody knows how to do substitution method. All right, look at number. So that is how to, whether it's a 2 by 2 matrix, if it is a system of equation in 2 variables or 3 variables, 4 variables, 5 variables, you can still solve them by Cramer's rule. Okay. All right, so let's go to, I'm not trying to do number 6, but I just want to write it out. You have already done an example like number 6. So actually, we have already done, I don't want to do that because I've already done something like that. Okay. So let's get a 3 by 3 and solve by Cramer's rule. And it's just going to be the same thing, and you can use cofactors to evaluate it, or you can actually use and then in this one, they just somebody wants to know if you know how to use the Cramer's rule. The cofactors right here. the best thing to do whenever you are given this is to uh, try to do the first row one. Okay, and then you have signs, plus, minus, plus, plus, minus, plus, minus, minus, plus. All right, so this should be minus. All right, so minus, plus, minus. And then plus, minus, plus. Okay, so I will just put my signs outside. And then I want to find the cofactors for the first row. So the first number is 3. 3 has plus, so 3. And then minor, the determinant here is going to be 4, negative 3, 2, 6. 4, negative 3, 2, 6. And then the next one is going to be negative 3. And the matrix of minus for the second one is, the matrix of minus for the second one is going to be this and that. Okay, so minus 3 is where I have, and so now I'm going to write the matrix in that minus. I have 4, minus 6, 2, and 9. All right, then the next one is plus, and that the position is x. So I'm going to put x here, and then let me draw the vertical line. Okay, and then I'm going to draw the vertical line here. And so I have the matrix of that minus is going to be 4, negative 3, 4, negative 3, and that's negative 3 here. Let's take that off. All right, negative 3. Okay, and the next one is 2, 6, 2, 6. Then I'm going to be evaluating all these cofactors. When I finish, I add them together. That will be the determinant. So the determinant will be equal to this one in parentheses. So I have equal to 3 into 4 times 6 is 24. 24 minus minus. Minus 2 times negative 3, 2 times negative 3. So I'm just going to have 24 minus is already there before, so minus 6, minus 6. All right, that's for the first cofactor. The second cofactor will negative 3, and then find the 2 by 2, evaluate the determinant. 4 times 9 is 36. 36 minus 2 times 6 is negative 12. And then the last one is plus x. And now I have 4 times 6 is 24. 24 minus 6 is plus 6. So D is given to me as 3. So I'm going to tidy up and solve for x. 24 minus 6 is 18. 3 times 18. So I'll quickly get my simplify. I have 3 multiply 18, and I'll get 54. So I have 54 here. And then right here I have 24 Minus minus actually is plus here. So 36 plus 12 is 48. Negative 3 minus negative 3. Or I can just put negative here. Negative. Then I have 48. 3 times 48. So I get my calculator. What is 3 times 48? And I get an answer. That's 144. So I put 144 here. And the plus x. 24 plus 6 is 30. So I have 30x. X times 30 here. Then I'm going to collect like terms together so I can simplify. So I can just put them into my calculator. I just put them here. 3 minus 54 plus 144 is equal to 30x. Solve for x. So I'll put all these things together. All right, so I can have negative 51 plus 144. All right, 144 minus 51, and I have 93, and I divide 93 by 30. And I have 3.1, so x is approximately 3.1. So the value of x is approximately 3.1. Okay, so you can use cofactors to solve the problem. By the way, you may not be able to use calculator to evaluate that. So this is another way of making sure you know how to use cofactors. So you should be able to solve number 8 with cofactors. So we use cofactors to do number 8 because the variable there will not let you solve. Then you can check your answer. When you finish, you replace your answer. So that, by the way, that is about cofactors, matrices. I just want to make sure we know that we can solve a system in 3 variables using Cramer's rule. Okay, so I'm going to just write the equation here and then. So we want to remember the formula though. So coefficient matrix is the coefficient of a matrix containing all the coefficients. So 4, 7, x, 1, then negative 1, 4, 3. This is a system in 3 variables. So 3 minus 1 and 4. So you find the determinants of this. You can use cofactors or you can use a calculator, whichever one is better for you. Then you find dx. Then you find dx. And dx does not contain the coefficients of x. So you got to be careful. So wherever the first column will be the constants, minus 5, 6, 41. The second column now will be coefficients of y, negative 1, 4, 3. And the third one will be coefficients of z, 3, negative 1, 4. And then you find the determinants of the 3 by 3 matrix, which is dx. And then you find dy, find dz too. Fine, let's find dy somewhere here so that we don't go too far. So what is dy? So if I'm looking for dy, wherever I see, I have to replace y with the coefficient matrix. So this is dy. And dy is also going to be a 3 by 3 matrix. And when you finish, you can decide to evaluate the determinants by cofactors or by a calculator, whichever one you decide to do. All right, so I want to make sure that when I'm doing dy, that I make sure that y, the coefficients of y are replaced by the constants. So I put the x, coefficient of x, 7, 1. Then when I'm going to put the coefficients of y, I put in the constants, -5, 6, 41. Don't forget that. And then the coefficients of z are 3, -1, and 4. And then you can find the determinants of y, dy, with your calculator or by cofactors, whichever is easier for you. Then you find dz. So dz will be, so dz replace z with constants the same way. So I'm collecting the determinants of z is equal to. All right, so I'll collect the first column the coefficients of x. The second column are the coefficients of y, -1, 4, 3. And the third column are the constants because I'm writing the z. So I have -5, 6, 41. Okay, so now evaluate this determinant using cofactors or calculator, and then you will later on, whatever your answer is, provided that your D coefficient matrix is not equal to 0. The coefficient matrix should not be equal to 0. Okay, so you want to find x is equal to dx divided by d, y is equal to dy divided by d, and z will be equal to dz divided by z, and you divided by this d. All right, so that's how you will do that. Okay, so let's get to partial fraction decomposition. See, if you're decomposing a partial fraction, it means that you want to simplify the factors of the denominator. So simplify the factors of the denominator. So we're going to remember that this is section 7.8, and the PowerPoint says it all. So what you want to do is go to PowerPoint and make sure you study that. But we're going to solve some examples on the partial fraction decomposition. So we can get to, let's see the first one. This is verifying a partial fraction decomposition. So first of all, they give you an easy denominator. You can actually look at that denominator and see that the denominator is a difference of 2 squares. So you can see x minus 1 and x plus 1. So they just decomposed it, but how do you, we can actually do that. So how did we get it to be 1 over? How did we get it to be 1 over? And so what we're going to do is we go to, let's do that. I'm going to go to my whiteboard. So I'm going to go to my whiteboard, and let's try and do partial, because it takes a lot of time. Okay, so we have decomposed the partial fraction. Decompose the rational fraction. So rational function into partial fractions. Into partial fractions. Okay, so the question in that particular one said 2x over x squared minus 1. Oh, in this we don't need any other. So what we have here, you just first of all rewrite, and when you rewrite the denominator, let's rewrite the denominator. I'm going to grab this and move it up. So if I rewrite the denominator, I have so I have 2x over x minus 1, x plus 1. All right, so on the right-hand side, I'm going to start with the decomposition. So I have a over the first factor, x minus 1, plus b over the second factor. There are two factors, x plus 1. All right, so what I'm now going to do is multiply, multiply both sides by this. And when I do multiply both sides by this function, I will end up having, I am going to continue here. So I will end up having 2x on the left-hand side is equal to, if I go to the right-hand side and multiply a by x minus 1, x plus 1 divided by x minus 1. So there is a factor that can cancel. And then plus b, I multiply b by, so I have plus, I can write that here. And it is going to be b into x minus 1, x plus 1, all divided by x plus 1. And x plus 1 will cancel. So we end up having 2x is equal to a into x plus 1 and b into x minus 1. All right, how do we get to get the value of a and b? If I want to get the value of a, I want to make this x equal to 1. So when x equal to 1, if x equal to 1, I'm going to say let x be 1. Let x equal to 1. So if x equal to 1, I have 1 minus 1, so b will be cleared, which means I now have, when x is 1 here, I have 2a is equal to 2x. Therefore, if I divide both sides by 2, I have, which implies that I now have x equal to 1. So x is equal to 1. So a is equal to 1. All right, when I want to get the value of b, I can say let x be negative 1. Let x be, so you do some manipulations using factors. You use factors and use properties of zero product properties. And when x is negative 1, you see that if you plug in negative 1 here, a will be 0. And so you have negative, so if x is negative 1, I got a is 0. So a will be 0. Then I have negative 2b. Negative 2b is equal to 2x. All right, so then I divide both sides by negative 2, and b is equal to negative 1. So then I can do the substitution and get the values of the function. So you want to rearrange. So when x is -1, see what you're going to do here, you put -1 here, and so you have -2b is equal to 2x, and so x is equal to -1, b equal to -1, and then go back and substitute. So that is how you are going to get a over, and then first of all you put in all the values of a and b. So you have having 1 over this and -1 over this. Okay, and this section is always long, so you got to be make sure you study that. Now let's go to a practice test and get one from a practice test. So we are going to the practice test and sample test. So this is a sample test, and let's do one partial fraction decomposition. And let's start with number 15. Number 15. So they already factored it out for us, so we don't have any problem factoring. Don't have any problem factoring, but if it's not factored, you have to factor it. So now the next thing I want to do is rewrite. So I'm going to rewrite. I have 7x plus 8 over x plus 8 into 8x minus 1. And on the right hand side, there are two factors that none of them is quadratic. So I will just write a over the first factor, x plus 8, and then plus b over the second factor, b over 8x minus 1. And then I'm going to multiply both sides by this quantity. When I multiply both sides by this quantity, the left-hand side will remain 7x plus 8. And if I multiply a by this quantity, the remainder is going to be a into 8x minus 1. If I multiply this quantity, then this one and this will clear. So I have b into x plus 8. Okay, and then the next thing I want to do is try to find a value that to make this quantity 0. So if x is 8, when x is equal to -8, b will be 0. b is equal to 0. And if I substitute -8 here, so I have -64. So I have -65. A is equal to, I go to the left-hand side, 7 multiply 8. Multiply 8, I have 56. 56 plus 8 is 64. 50 is 64. And then divide both sides by -65. Divide both sides by -65. And so A is equal to 64, -64 over 65. So I have the value of A. This is the quantity. This quantity is the value of A. And so I will find the value of B the same way. Before I find the value of B, I want to know what value of A that will make B 0. Okay, so I found the value of A. This is the value of A. And there are so many ways you can do the manipulations. Okay, now when I want to find the value of A, so B, what I'm going to do is, what can I do to get A here to be 0? What can I do to get A to be 0? Okay, and what I can do is solve this one, 8x minus 1 equal to 0, and then solve this. So it's going to be 1 over 8. So I'm going to say, let x equal to 1 over 8. So if I replace this quantity by 1 over 8, then I have A equal to 0. And if this is 1 over 8, I have 8, 1 over 8. So I have 8b plus, I just have 8, 1 over 8. Alternatively, I can write 65 over 8. So I can say 65 over 8b. And then I go to the left-hand side. Left-hand side, when I multiply the 7x by 1 over 8, I have 7 multiply 1 over 8 plus 8. 7 times 1, 8 times 7 is 56 plus 1, 57. 57 plus 8 is going to give me 65. So I have 65 over 8. Divide both sides by 65 over 8. So B goes to be 1. If I divide both sides by 65 over 8, I have B is equal to 1. So B is equal to 1. So now I will rewrite the partial fraction. Okay, so I've got the value of A to be 64 over 65 negative, and the value of B to be 1. So now you got to rewrite the rewrite. So when you're rewriting, you come over here and put in the value. So value of A is negative 64 over 65. So instead of A here, you can now rewrite, put this as 64 over 65 negative. And when you come to here, this is 1, just 1. And so B and A will not be there. So the partial fraction decomposition of this will contain a negative 64 over 65 in the numerator here, and B is equal to 1 in the denominator. So let's go and find another one. And by the way, this unit 4 has only 3 sections, 7.1, 7.5, and 7.8. All right, so when we come to this one, actually still has still factorized. So the same method, you can just decompose it, start x. You don't have to find the factors because it's already found for you. Minus x minus 17 equal to, then you can write A over x plus B over x plus 1 plus C over x minus 1. The same way we did the other one. You start finding the values of A, B, C. And when you finish, you replace A, B, C with the numbers you found. It takes some time, but you have to try your best to try and decompose it. For example, if I want to find, first of all, I have to multiply both sides by this. If I multiply both sides, then I will have a into x plus 1, x minus 1. If I multiply both sides, here I will have b into x minus 1, x minus 1. And then if I multiply both sides by c, I have c into x and x plus 1, x plus 1. All right, so then the next one is find what will make this one 0. If I substitute, when x is equal to 1 here, this is going to be 0. And if this is 0, this is going to be 0. So when x is equal to 1, b will be, actually, b will be 0, 2. And then c, let's see what happens to c. C will be, okay, let's see, this is going to eliminate when x is equal to 1. X is equal to 1, c will eliminate. When x is equal to 1, b will eliminate also. Let's see. No, c will not eliminate. Okay, so this will eliminate when x is equal to 1, and so we shall have 2c. So 2c is equal to, on the left-hand side, so when x is equal to 1, we have 2c. 1 here, I have 2, minus 1, minus 17, minus 18. So minus 18 plus 2 is minus 16. So minus 16 is equal to 2c. So we have that c is equal to negative 8. So now that I have negative 8, I do some manipulations again to get the values of b and c. So b and d, I already have the value of c. Knowing the value of c helps a lot. So I'm not dealing with 3 variables. Actually, so you just take it easy. And then I think we will be stopping here. Right.